In this video, we will discuss feature-based modeling, and in particular central features. These features are the most commonly utilized for creating parts, and are often the first features that CAD modelers begin using. Central features are essentially features of the total solid body that develop based on a center or centerline of some sort. Though the solid would also be dependent on some set of dimensional quantities, the direction for which the solid would be formed is dependent on the center/centerline. Consequently, there are three main types of central features common to several different CAD platforms: extrusions, revolves, and sweeps. The first type of central feature is the extrusion feature. An extrusion is an addition or subtraction of a geometry along a single unchanging axis, based upon a provided sketch and a distance along the axis perpendicular to the sketch, to develop the part. Because the extrusion only operates on a single axis perpendicular to a provided sketch, you only need to use one plane to make an extrusion. An example of an extrusion that adds material is taking this sketch of a square and converting it into this rectangular prism by quote-unquote extruding the square out. As you can see, the cross-sectional shape of this rectangular prism is the original square. In contrast, an example of an extrusion that removes or subtracts material is taking this same rectangular prism and this circular sketch on the surface of the rectangular prism and extruding material out from inside the prism. The next type of central feature is the revolved feature. A revolve, just like the extrusion, is the addition or subtraction along a single unchanging axis, except that where the extrusion operates along the axis, the revolve rotates around the central axis instead. This is another example of a central feature that only needs one plane to make the feature. An example of revolve that adds material is taking the same square as before. This time, however, instead of using the center of the sketch, we use this edge of the sketch. The entire sketch then revolves all around this edge to form this cylinder. In contrast, you can also remove material using the revolved feature. Take, for example, the rectangular prism we created previously. By creating this semicircle on the top of this prism, we can revolve the semicircle around the center line to form a sphere. This time, however, instead of adding a spherical shape to the top of the prism, the spherical shape is actually removed from the top of the prism, like so. The final type of central feature is the swept feature. The sweep is similar to an extrusion, except this feature can occur across many directions, as opposed to the extrusion, which operates only in one unilateral direction. As part of the fact that the sweep can operate in many directions, it requires two components: the cross-sectional sketch, and the defined path, which must start connected to the sketch, but then branch off perpendicular to the cross-sectional sketch. As a result, this feature operates in two planes, one for the sketch, and the other path that the sketch follows. An example of a sweep that adds material is when we take this circle, and this twisting path, that begins perpendicular to the circle and use them both to make this pipe. As you can see, the sweep is better than the extrusion, when the same cross-section is needed in multiple directions and the body is wholly connected together. In contrast, we can create a circle at the same end or the other end of the sweep, or at any point along the path, and then we can use the same path to remove material equally from every part of the sweep. Thank you for watching this video. See you in the next video.